Next, let's talk about some definitions. I've been using terms up until this point that are specific and maybe a little confusing. For instance, I haven't said this yet, but the phrase that you might hear me say when we're working on Lab 1 is, okay, the instance of this object doesn't seem to have the information that you need. What does the class say? There's a lot of information in those two sentences. And object, instance, and class in many circles are used synonymously, but they are actually different concepts. Okay? So we need to have common definitions so that when we talk about these things, we know what we're talking about. So let's start with class. What is a class? The simple definition is that it's a code-based template for your object. The class is what defines how an object behaves, what data is stored about and within that object. And when it comes right down to it, your class is your code. Right? Your code defines how your objects will work generally. It defines what behaviors are available, what state is contained within it. And in fact, when we get there, you'll see that your code starts off with the word class. And almost any language will have this or some equivalent. The languages that I've coded in the most are C# and Java. And it is not the first word, it's the second word in those languages. In Python, it's the first word. In those languages, you get a visibility modifier first. So it'll say like public class. But in either language and in Python, you define your code, your class, with a class definition where the word is in it. Okay. So the class is the template. What's the object? What's an object? An object is a single instance of a class. So objects and instances are sort of synonyms. The object is the same format as the class, but it contains its own state. And if you want to think about it this way, the object is the operational version of a class, and the instance is a single copy of that operational object. So for instance, lists all have the same basic structure, but can have different lengths and content and values and variables and all that stuff. We can say L1, right, equals nothing, and L2 equals 1, 2, and a third element, which is a list of 2 other aspects, right? Now our code has 3 instances of lists, right? We have L1, we have L2, and we have the element at index 2 of L2. All of these things have different lengths. Appending to them will result in different behaviors, different states. The behaviors are the same, but the states are going to change, right? If we call .append X to any of these, you're going to have different things. X would be added here, or X would be added here, or X would be added here. The length will be different. This now will be 1, this will be 4, and this will be 3. They all follow the same template. They all follow the same format. They all have the same internal structures and external behaviors. But what is in each object, each instance, is different. Okay. Now we have this idea of an instance variable. The instance variable is the thing inside of the class that holds the data, right? If we wanted to store, if we wanted to store, going back to our video game idea, our PC's HP, right? In a procedural language, we'd say PC underscore HP and give them 100 hit points, right? Well, in our object-oriented programming, we might want to say PC dot underscore HP equals 100. We would need a variable inside of the instance of the object to store that information. Variables are how, no matter where we are encoding, how we give a name to information in order to be able to access it later on. Instance variables define what sort of state will be internal to any given class and what sort of information can be held by any given object. So how do we access that information? Well, we do that via methods. That's how we get it, that's how we change it, whatever. What's a method? Because we've talked before, and methods and functions are similar, but they're not the same. What's a method? A method is a subprogram that is similar to a function, but that is specifically defining an aspect of an object's behavior. And methods have access to all of the instance variables within an object. So when you're coding it at a class level, you know, hey, I have these variables available to me, right? I'm defining a damage method, right? I take damage, and I'm not going to use full I'm not going to use full syntax, right? But I've got a damage method, and I know I have an HP. Well, let's see. If my status is 2, right? Because we said 2 is poisoned. Then HP equals HP minus D times 2. We'll assume that poison doubles damage. If you're poisoned, you take double damage. Else, and I don't have the space for this, HP minus equals D. Subtract D from HP and reassign it. Hey, look, we have access to status. We have access to HP. And we have access to the information that came in. And we might return something. We might then return the HP value. I don't know. This is not quite the proper syntax for Python. That's okay. We'll get to that in a minute. The concept remains that methods are based on the internal structure of a given object. Otherwise, it's defined and sort of follows the same rules as a function. Methods and the parameters and return values associated with each method, these are the messages being passed. Okay? These are the messages. I took damage. I took 10 damage. Well, now you got 80 hit points because you're poisoned. Right? That's how the objects in these languages communicate with each other. And remember that methods inherently are going to deal with the internal structure of the given object. If they don't, they work better as functions. Right? If remember, mathematical concept, a function maps inputs to outputs. Right? F of x goes to the domain. Right? Takes x in, spits out f of x. No internal structure other than the equation. Same concept here. Then we have interface. Interface, when I say, what's your object's interface? When I say, what's your program's interface? When I say interface in general, interface conceptually refers to how you deal. I almost said interface there, how you interface with something, how you interact with a system. In this case, it's the set of all publicly visible methods for a class or object. Right? The interface defines how objects interact with each other. So when I say, what is your program's interface? I'm saying, what can I deal with as the user? When I say, what's your objects or your class's interface? What I mean is, what methods can be called? And what kind of information will they return? Right? When I give you a lab, I will frequently give you the interface for an object and the behavior that it is supposed to accomplish. How you accomplish that is up to you. Now, there are going to be some best practices, and there will be some pretty, standard results. But when it comes right down to it, assuming that you are following a good design, how you accomplish it is really up to you. The internals of your object really is up to you. And as you'll see, I will provide you with a tester program that is already written. And the nice thing is, if we agree beforehand that your program will have these methods and will behave these certain ways, my tester program doesn't have to change at all because we've agreed upon that interface. Dot upper returns whatever is internal to the string, except as an uppercase string, as an all uppercase string. Dot append takes whatever value you give it and changes the list so that that value is now the last element of the list. Dot strip takes a string, takes whatever's inside the string and returns that string with all leading and trailing white space removed. Again, how's it work? We don't care. Black box. But me knowing that means that I can start to code my application without ever having to have that working other object. I'm never going to be able to test my code, but I can start to implement it. Now, for some languages, those of you who have experience with Java or C#, and they're not the only languages that use this keyword, but they're the two languages I used, and I know they use this keyword. An interface is a very specific thing. It's a file that syntactically and structurally defines methods that a hierarchy of objects have to implement. But if you think about what that means, right? Well, if I say that my object is a comparable object, then I need to implement the .compare to method. well, I need to implement this aspect of the interface. I have to give this method with these inputs and these outputs. So the interface object, the interface file, syntactically defines what kind of interface an object is supposed to have. Right? We don't have to worry about that in Python. We are going to sort of backdoor that later on. We're going to create a specific kind of file, a specific kind of class called an abstract class that defines interface. And we'll do that later on. That'll be down the road. You'll see abstract classes towards the end of this module, though. So pay attention to that.